This is the Pulley Intro Lab that we're going to go through some introduction about the Pulley system. So read through the introduction, and I did a few measurements before the lab. So right now I am going to share the data with you about that. So first of all, I need the scale that I'm using. So the scale I'm using, as you can see, is from 0 Newton all the way to 2.5 Newton. So that is the scale I'm using. And the mass of the scale is 50.43 grams. Be aware those are in grams, so later on you might need to do some conversion. So here is the pulley. So this is what we call a single pulley with only single wheels on it. So if you read through the introduction, as you can see, we will use single pulley in quite a few of the experiments that we're going to do in this lab. And the mass of the single pulley is 16.79 grams. So 16.79 grams. Now, another thing asks for a double pulley. So for us, for my demonstration here, I use 2 pulley, and later on I'm going to connect them together with the pieces in between. So I also put in the balance. The mass of the double pulley, it is 39.90 grams. 39.90 grams. As you read through the introduction here, there is 4 different systems that we are going to do. A few different things that we need to be aware of. Throughout this 4 system, the mass of the 4 different trial are a little bit different. So I measured it also and then give you the data. So for system A, the mass of the object that we're going to lift it is 101.28 gram. For the object in system B, it is 101.64 grams. And also for system C, it is 160 grams. So 100.6 gram. And for system D, it is 100.83 grams. So here is the system A. As you probably can tell, on the rope that I have black markers to mark between. So each different black marker is actually 20 centimeters difference. The first thing I'm going to do is make sure it goes straight up and down. So I'm going to adjust the side a little bit. But as you can see right now, hopefully both lines are straight up and down. And I'm going to pull it on the scale, and then it will give me a read. It's about 0.9 Newton. That's what I have. Actually, wait a second. I'm going to read that again. Actually, it's not 0.9. So go on eye level. Wait, it is about 0.7 Newton. So that is the force that we use, or what we have from the scale. So after finding out the force, the next thing I need to be aware of is the distance. The distance input and the distance output. So at this moment, I don't really need the scale. I can just use my hand to pull on a string to replay this again. So as I said previously, on the rope, I have a set mark as 20 centimeters apart. So I started from the first mark and pull it all the way to second mark. What I can do is make sure at a stable sit, and I'm going to measure how far away from the table. Right now it's about 3 centimeters away from the table. Now I'm going to pull it all the way up to that reference point. Now it shows 23 centimeters above the table, which means I pull on a string 20 centimeters, and the object was raised also 20 centimeters. So after recording those data, the first thing you need to think about is the mass raised in kilogram. So think about object 1 was 101.2 grams. But what's the mass I'm really raising? Because what happened here is I have a force of apply which is pulling it down. But think about a free body diagram. The scale is right there. So even if I don't pull on it, the scale has a force of gravity going down. So that's one of that you have to keep in mind. What is the mass that you are really raising it up? So I'll let you figure that out. If you have questions, please let me know. So that is the system A. Now here is the system B. Similar setup as what the picture is shown. What I need to do is just unhook this and then put it on the scale and then pull it up. Let it stay and make sure the strain is perpendicular to the ground or both strains are parallel to each other, so have a more accurate read. So for me, what I have on a scale, it is about 0.7 Newton also. So it's same value as the system A. After finding the force that needed to pull the system up, the next thing I need to find is the distance. As previously, I also have the marker on there already. So what I need to do is pull the system 20 centimeter from the mark that I have. Before that, I am going to measure. This is about also 3 centimeters above the table. Now I'm going to try to pull 20 centimeter up. So it shows 13 centimeters above the table, which means the whole system I pull 20 centimeter on this side, but the mass is only going up 10 centimeter because 13 subtract 3, that is 10 centimeter. So the distance input is 20 centimeter, but the mass was only raised 10 centimeters on that. Now take a look at this diagram. What is the mass that you are really pulling it up? We have the mass of the object, which is 101.64 grams. But don't forget, there is the pulley right there. So pulley originally also have a force of gravity going down. So keep in mind, so keep that in the thought and to calculate the mass raised in kilograms. So that is the system B. So here is the system C. As a setup, as the same as the diagram shown. So what I need to do right now is figure out what is the force I need to pull up this system. Make sure it is also going straight and up and down, so I need to do a little bit of adjustment here. Oh, make sure it is straight up and down. And then on a scale, I will read, on a scale eye level, it is 0.5 Newton. So it only takes 0.5 Newton to move up the object. The next thing I need to do is finding out the distance. Similar as the previous ones, I always mark that 20 centimeter on a reference point. So it's right here, it is 20 centimeters apart with the black dots. So all I need to do is pulling the system 20, or pulling on the rope technically, 20 centimeter. So right now I'll measure the height of the object at the relative point, which is 5 centimeter above the table. Pulling 20 centimeter on the rope. It is 15 centimeters. So which that tells me I pulled a rope 20 centimeter, but the object only goes up 10 centimeter because 15 subtract 5, which is 10. So that is the distance. Now let's take a look at the diagram for system C. So a few things need to consider. 100.60 gram of the object, but technically you still have that pulley. Pulley has a force of gravity going down. And don't forget now, the scale, you're pulling it downwards. You're not pulling upwards. So when the pulley just hanging, or the scale is hanging there, you have a force of apply to pull it. But don't forget, originally you still also have a force of gravity going down. So it's a little bit tricky here to think about the mass. Draw the free body diagram and list it and see what is really the mass you're pulling it up. So that is for system C. Now here is the system D, which is more complex than the previous one we see. This is involved with the double pulley. You have a double pulley on the top and a double pulley on the bottom. So the object has been raised is 100.83 grams. So similar concept, I am going to put a scale and hook it up and to find out what is the force that I really need to pull up the object. Pull it on the scale and make sure it's hopefully straight and up and down, and wait a little bit until it settles. As I can read, it is 0.3 Newton. So it only needs 0.3 Newton to move up this object here. Now here this is a little bit special because the whole system is a little longer. So what I did is actually I marked twice for the 20 centimeter mark. So I'm going to let it set to the first relative point. What I can do is the first thing I'm going to do is measure the distance when it's at the first relative mark from the ground. It's right here, let it stay. So 12 subtract 30, so it's about 18 centimeters above the ground. Now what I can do is, this is the first 20, second 20. So now what I need to do is I need to this actually works. So it reads as 2, which means the whole ruler is 30 centimeters long. So 2 subtract 30, it is 28 centimeters. I pull on the rope twice for 20 centimeters, which means I pulled 40 centimeters on the rope. And it raised from 18 centimeters above the ground to 28 centimeters. So which means I pulled the rope 40 centimeters. The object raised up for 10 centimeters. So that is the distance you need for this system D. Next, we're going to move on to taking a look at the diagram. So looking at the diagram, the object is 100.83 grams. But don't forget, you have a double pulley there, which has a force of gravity intentionally going down. And here the scale is also being pulled downwards, which means there is a force of apply going down, but also the force of gravity there. So you need to consider that also for the mass of the total system that you're pulling. So that is the end for system D. You have all the data you need, then you have to do some calculation. And for the second calculation table, you will need to find out the IMA, AMA, and identify what is the number of the lifting strains. And at the end, you need to find out the efficiency. And don't forget to fill out the conclusion page at the end.